Next, we have Kate Connolly, who will be giving a talk towards sustainable buildings, a case study of classroom air quality and rooftop gardens. Kate.
Hi, everyone. Thank you, Evan. My name is Kate Connolly, and I'm a fourth-year PhD candidate and urban trainee. Today, I'll present a project that I've been doing in collaboration with the former trainee, Sarah Beth Buckley. And this has really highlighted how we brought together our two fields of environmental health and biogeosciences by studying schools, indoor classroom air quality and ventilation, and the benefits of rooftop gardens. Next slide. So this research origin story goes back to the urban kickoff in September 2018. You can click again, where our groups of students discussed CO2 concentrations indoors and in urban environments. This included a presentation from Sarah Beth Buckley and her dissertation work on high CO2 concentrations in BU classrooms. You can click again, Evan. And of course, culminated with our visit to the CAS rooftop, as you can see here. Glad this picture came up again. Next slide. So we met up a few months later to discuss this project idea about monitoring CO2 from indoor sources, also known as humans, and then modeling the building airflow to estimate how ventilation could be improved to mutually benefit students inside and plant growth on the rooftops at the BU Academy. Next slide. In Sarah Beth's dissertation work, she found that spinach plants grew larger at the exhaust vent compared to a control fan on rooftops as measured in dry biomass on the left picture here, with a higher median value in grams. And you can also see this in the picture on the right. Exhaust vents have air coming from inside the building, which is rich in CO2, while the control fan has the recirculated air on the rooftop. Next. So in our study, we measured CO2 inside various classrooms, and we found rather high levels at the BU Academy, which is a high school on the BU campus. In this graph, which shows CO2 concentration on the y-axis over time on the x-axis, we see that levels frequently went above 1,000 ppm during occupied class times. And this serves as a reference for inadequate ventilation, as seen here by Mass DPH. You can click again, Evan. Also, since, one more time, additionally, monitoring locations were within the building, as we see here labeled inside, as well as exhaust vent, which is on the rooftop. And this shows that the concentrations found on the rooftop were well within range for increased plant growth. Finally, we are focused on quantifying the different aspects that come into play in this urban system by looking at energy, cost, and carbon considerations through recommendations like increased ventilation to improve IAQ and ventilation, which will improve IAQ and health inside, while being balanced by the benefits of rooftop gardens, which include increased insulation, decreased energy use, local cooling, and innumerable mental and physical health improvements for occupants. Thank you.